So, Assalamualaikum and greetings to all. So, this is the lecture for hypothalamus and thermoregulation, and I will divide this lecture into 3 separate videos. So, the learning outcome for this topic, the first one is to describe the functional structure associated with thermoregulation and explain the physiological mechanism of thermoregulation, and the third one is to describe the consequences of abnormalities in the thermoregulation. For the first video, we will talk about the physiology of heat gain and heat loss in our body. So, thermoregulation is regulation of the temperature. So, the purpose of regulation of the temperature is to maintain our core body temperature in a hemostasis range, which is 37 plus minus 0.5 degrees Celsius. So, the center for this regulation are in the hypothalamus location. And the function of this center is to set the body's temperature set point. So that means the hypothalamus area will set, let's say, the body temperature that ideal for our body is 37. So our body then will respond to achieve this set point of temperature. So this is the temperature homeostasis. So how do we achieve this? Is through heat gain and heat loss balancing act. So heat gain. So heat gain in humans generally is through the byproduct of cell metabolism. You know, cell metabolism, the byproduct is heat. So the heat in our body are generated through this cell metabolism. And naturally, cell metabolism, they can vary during the body needs. Your activity, your age, whether you are healthy. So all of these, they can affect cell metabolism. And as a result of this, they affect the amount of body heat generated. So about heat loss, because most of the body heat generated through cell metabolism, they are generated in the deep organs or in skeletal muscle. And we have the skin and subcutaneous tissue. So these, they act as insulators to maintain all of this heat so that we can maintain the core internal temperature. So this heat is released from our body, usually they're transferred to the skin through the blood flow, which can vary depending on body needs. So you all know the vasodilation and the vasoconstriction. They also involved in body temperature regulation. So, for the heat loss from the skin surface, there are 4 methods. You can divide into 4 methods of heat dissipation through the skin. So we call it heat dissipation. So the first one is radiation, the second one is conduction, third one is convection, and the fourth one is evaporation. So we start with radiation. So the human body radiates infrared rays. I'm sure some of you have seen this before, whether in your video games or in movies. They have this infrared camera that check the amount of heat produced by the body. So this shows that our body generates heat. So this heat are then transferred from the skin to the environment. So this is radiation method of heat dissipation. So the transfer of energy based on electromagnetic principle. So you don't need to know in detail about this principle, but what you need to be aware is the quantity of heat loss through radiation is more effective or increased when the body temperature exceeds the surrounding temperature. So when you are in cold surrounding, or usually you will lose more through radiation. The second one is through conduction. So conduction is common enough term, means you conduct from one place to the other. So when the skin is in contact with other surface, it transfers the heat. But this only occurs when the object in contact is colder than the skin. So this makes sense. Huh? So you touch an, a block of ice, so you transfer the heat to the block of ice. But if you touch a hot pan, you touch a hot water, usually it's the reverse. That means the heat from the things that is hotter is transferred to you. So with regard to heat loss, usually occur when the things that you are in touch with are colder than the skin. So this is an example that we can see normally is when you're in contact in cold water. So if you are in cold water, if you, let's say you drown in a cold lake, so you can develop hypothermia very quickly because you lose a lot of body heat through conduction because you're in contact with cold water. Because water can absorb far more heat than air. So another thing that you need to be aware when we talk about conduction, it also happens when our skin in contact with air. So it's not necessarily just mean that when you contact in solid object. So in normal condition, when our skin is contact with the air, there is also conduction happen there, but it is less effective. They say when we compare when you in contact with cold water. So that's why if the water temperature is very low, the heat loss through water conduction is multiple times greater than heat loss through air conduction. So that's why you take a shower, cold shower, you cool down very quickly rather than just depending on conduction through the air. The third one is convection. So as I mentioned before, our skin in contact with air you have conduction. So that means when the heat is transferred from our body to the air, so usually the air will heat up. So when the air is heated up, it's no longer able to take the heat from our body because it is become warmer. So convection is occur when the heated air is replaced with new unheated air. So this is the concept of convection. So the example, the most common one, if you sit in a closed room without windows, that means you don't have air circulation. So the air that is in contact with your body, they become warmer because they already take the heat from your body. And if they are not replaced, that means they stay warm. So, but if you have wind, so wind, that means you have air circulation. That means the air that was heated through conduction, they are replaced by new air that is colder. So then they can continue to remove heat from your body. So the classic is when you open the fan. So when you open the fan, that means the air keep on being replaced. So that's why you feel cooler because you lose more heat from the body. And if you want to develop hypothermia in convection setting, usually you in a cool, windy environment. So that means you have a blizzard or something like that. That means you lost excessive heat through convection, where the cold air absorbs more heat and is rapidly replaced by new cold air. So this is example of another hypothermia. So you need to be able to differentiate loss of body heat through conduction and convection. Why? They are different. So the last one is evaporation. So this I think you all know already. So, but one thing you need to be aware is evaporation is the only natural method of losing heat when the surrounding temperature exceeds the skin. So the radiation, the conduction, the convection is only when your body is hotter than the surrounding. But if you are in the warm climate where the surrounding environment is hotter than the temperature of your body, evaporation is the only way to lose body heat. So, you'll know evaporation through sweating. So you know sweating, you have the sweat gland and skin, and then the water, the sweat will evaporate and it will take the heat up from the body. And then one thing you need to be aware, if you still remember in your first sem, we talk about insensible water loss through the skin and lung that occur without sweating. Those also can help dissipate the body heat. So we combine all of this. combine all this in the normal settings, as you can see here, most of it are removed by radiation. And then evaporation, usually 30%. And this depends on whether you are sweating a lot or not, or whether your body are exposed. So depends on that, the amount of evaporation. The same with convection. If the air motion is high, then usually the convection percentage will be higher. And conduction, usually in normal settings, usually we are not in contact a lot with cold items, cold objects. So usually conduction is very low, particularly if our body also is not exposed through the air. So usually in normal settings, all these four are work simultaneously to dissipate the heat generated from the body. This is the end for the first video. In the second video, we will talk about thermoregulation.